Okay, class, today what we're going to do, we are going to do another demonstration to get you to understand about volcanoes. And I know that you already have had experience with volcanoes when you're younger in 6th grade, 5th grade, and so forth. But in this class, we're going to try to figure out what and how can studying and learning about volcanoes and earthquakes, how can that help us understand the internal structure of the earth? How the earth is organized inside, okay, internally. So today we're going to do a little experiment, and I have my helper here. He's my helper. This is my son James, and he's going to be my helper today, okay? So basically what we're going to do, he's going to actually be the one doing the experiment. Can you do that for me, James, today?
Yeah.
All right, here we go. So I'm going to read the directions, and then I'm going to let you do most of it. How about we share it, okay? So the first direction is, it says work with your group. Hey, we're a group. Ooh, he probably embarrassed about that. Anyway, to set up your volcano model as shown below by following these steps. So the first thing you do, it says, James, can you do this for me, James? This right here is going to be our, this right here is a clear tube. Here you go, James. Put the clear tube into the mouth of the white volcano. Yep, there you go. And then it says here that I should put on the base. Well, I forgot to bring the base home, so I don't have the base here today. But let's put the base right here on a saucer. Okay? Put all that in a saucer. Then it says we're going to place 5 scoopfuls of baking soda. Where's the baking soda? Oh, here it is, James. Can you get 5 scoopfuls of those? Yep. Mm-hmm. And we're gonna put them right inside of the bottom of the volcano tube. So 5 scoops. Yep. And that's 1. You want to count out for us, James? Mm-hmm. Yeah, it doesn't. Yeah, he has to be exact. Are you getting him doing it? You can see what he's doing, James, DJ.
2.
All right. That's good. I kind of like piling on. That's right. That's good.
3.
All right. Get a little bit more. Good. So we're putting our baking soda into
4.
the mouth of the volcano, right? That's good right there. Okay. Good. And then the next step says use the graduated cup to measure and pour 5 milliliters of less gassy. You can put one more. Yeah, go ahead. Put another one.
Was that 4? Oh.
That was 4. Put one in. That was actually 5, but it's okay. Put another one in. It's actually better if you put a little bit more in for this part anyway. Okay, so step 4 says use a graduated cup. Can you find a graduated cup for us, James? Right there, the graduated cup. There you go. The graduated cup. And you're going to pour 5 milliliters of less gassy magma. And you guys know what magma is, right? Magma is what is inside the volcano. And then when that magma reaches the Earth's surface, then we call that, what do we call it? Somebody tell me. What do you call it? What do we call it when the magma reaches the Earth's surface? Called?
Lava.
There you go, lava. James, you do that. And DJ, okay, good. So here, James, get the less gassy magma. So look, class, we're trying to figure out what happens if we have less gassy versus more gassy, okay? So, James, you need to come up, put 5 milliliters in there. You can use both hands. Your hands aren't broken, huh? Okay. 5 milliliters. Can you see where 5 milliliters is? Okay, good. Now it says, without disturbing the model, you're going to pour that into the tube. Pour it into the tube and see what happens. Oh, what did we just make there, guys? We made a volcano. Okay, now this one is the less gassy magma. Let me caution you, we have magma and we have lava. Lava is when it reaches the Earth's surface, and magma is when it's inside the chamber of the volcano, okay? Now, who can tell me, let's take a little side break. What kind of rocks do we have in my hand? What's the name of this rock? Anybody know the name of this rock? What's the name of that rock?
Sedimentary.
Yeah, that's a good guess. That's a good guess too, but no, that's wrong, guys.
Igneous.
That's an igneous rock, and this looks like somebody's countertop, doesn't it? Granite. Okay, that's granite. And then we have, now you guys all know this one. Well, you know this one. You guys play Minecraft. What's it called?
Obsidian.
Obsidian, that's right. And this obsidian is also an igneous rock. So igneous, granite, obsidian. And then we have, in my hand, we have gabbro, which is also an igneous rock. Now, we have some other igneous rocks over here. Do you see how these rocks are not the same as this rock? Can you see how they're different? They're all igneous. We're trying to figure out why this was so smooth. And these are, look at this. This one has all kind of craters in it. Why is that? Well, I'm not going to give you the answer until after our experiment. So let's keep going on with our experiment. So we are now in step 9. Step 9 says, want to read this for me, James? What do I do next, step 9?
Use the graduated cup to measure and pour 2.5 milliliters of more gassy magma into the volcano tube.
Okay, wait a minute. Let me first rinse this out. Okay. All right, so it says, do it again, to pour what? 2.5 of more gassy magma into the volcano tube this time. Okay, James, so can you get to 2.5 more gassy magma? He's going to rinse the step, I skipped step. Step 7 says rinse your volcano model. So that's what we just did. And he's rinsing the graduated cup. If you look over here, class, we see we have a graduated cylinder. We have a beaker and another beaker, and we're not using these items today, but I think it's important you know. Okay, good. So, James, 2.5 of the more gassy. That's right. This time only 2.5, not 5. You open a container. He knew that, everybody. He knew that. That's my baby. Baba John's. Okay, I'm sorry. He's not a baby anymore. 2.5 milliliters. It's just 2.5. How was that? Is that 2.5? Can you see it? Now, good thing, like this, you look down like this, and you can see it like that.
No.
If you bend down, like this, James, see? I can't see it all. Is it 2.5? If it's close enough, but that's going to be just fine. Okay, great. So you're going to pour that into the model there.
You put this stuff in?
Nope. Now I'm following directions. You got to follow directions. Okay. Follow the procedure. I mean, yep. Put 2.5 in. And then it says dip your finger into water. So I'm going to come over here and get some water. And I'm going to do this part first, James, and then you'll have a chance to do it after I do it, because it could be dangerous if you don't do it right. And then it says, use my wet finger to moisten the bottom of the rubber stopper. So now it's nice and moist. And then, what does step 11 say, James? So now I'm doing step.
Dip the bottom of the stopper into the baking soda so that a thin layer of baking soda sticks to it. Gently cap the volcano tube with the stopper. Try not to spill any baking soda and insert the stopper snugly in the tube. Quickly turn the entire volcano model upside down, then put it back on the table, right side up.
Okay, here we go. So we got our baking soda. We got our more gassy magma inside our volcano chamber. And I'm making this nice and snug. And DJ, I suggest you stand back a little bit, because what you're going to see is going to happen. Oh, I did a little wrong. Wait a minute. That was kind of fast. Did you get that?
Oh.
Okay, you get it? All right, James, you want to try it? So all you need to do, James, we actually don't need more of the more gassy. So go ahead, dip that in there. And you want to make it nice and snug. So push it down pretty hard. Okay, good. And I use both hands. No, you're going to use one hand like this. One hand like this. Put your thumb over that. Oh, your right hand is like this. So it's gonna be like this, and you're gonna tip it like that, okay? Go fast. Make sure it's gonna be tight and nice and tight. Is it tight? Okay. Fast, fast, fast. Move your hand. Wait a minute. Okay, so this time we're gonna rinse it out again. We'll try it again. And we're gonna do it again, okay, James? Okay, here we go. So rinse it out, got all that extra water out there. And let's put, and I don't really like, I know you did all that measurement, that was good. That was nice of you. Okay, so 2.5, that's about 2.5, right, class? Okay, we're estimating, right? Okay. All right, now you're gonna get this wet. And then you're gonna dip it in. Now make sure it's nice and snug, okay? It doesn't matter. That's good. And you're gonna push it down nice and tight, okay? And use 2 hands. Yep, that's good. The more pressure, the better. You gotta use 2 hands and do, okay? That's good. That's not how we do, but that's fine. You can do it that way. Go ahead. Fast, baby, fast. Okay, you get it. You can get it go up, DJ. You missed it going up.
You go like,
okay, let's
whoa.
try it again. Try it again, James. He missed it. That was a good one.
Okay.
Oh, that was a dud. Okay, let's try it one more time. That wasn't a dud. That was good. But I know we can do better, everybody. I just know. I got a feeling we can do better. So we're going to try that one more time, James. Because I want you to have the experience. Okay, what's my... So that's about 2.5, right? 2.5. Okay.
How to control variable.
That's absolutely right. We don't. In fact, this is not even considered to be, this will not be considered a fair test because we use 2.5 of this and 5 millions of that. So we couldn't even compare it.
Not measuring. Gas.
That's right. You're right. Fast. Gotta be fast. You get
Whoa.
that? You get it?
That one went high. I didn't really get the top of it, but I saw it.
Okay, good. So, class, here is, we talked about we have, which of these rocks here, can you see the rocks here? Which of these rocks here would you consider to be from a volcano that had more gas or less gas? Which of these do you think had more gas or less gas? Let's look at them. If it's more explosive, what kind of results are you going to see? If it's more explosive, then you're probably going to have something like this, right? So a more explosive volcano, the one that has more gas in it, is going to create igneous rocks that have craters like this, okay? One that is slow moving is going to create a nice little rock like this, like our obsidian. So who can guess what was in our more gassy? What was in this one? Anybody know? What
Vinegar.
was this? Vinegar. Okay, right, that was vinegar. We used baking soda and vinegar. This one was actually vinegar as well, but it was a lower concentration of vinegar. So class, once again, we're going to use ideas about volcanoes and earthquakes to help us to figure out how the earth is structured internally. So we're going to use volcanoes and earthquakes, our knowledge about that, to help us figure out what the inside of the earth looks like, what it contains, what the layers are, and so forth. Let's give our helper a hand here. Let's give him a hand, everybody. Come on, give him a hand. Good job, Jesus.
He could use a hand.
Yeah, he can use a hand. Ha, 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 ha. All right, thank you, class. See you in a little bit.